Hello, assalamu alaikum. My name is Sadik Yasir Tauki and my ID is 1606194. My project was to build 4-bit PC using VerilogHDL. These are the architecture of my PC. I have used input register, output register, RAM, stack memory, and arithmetic logic unit. Some of the unique features of my design was the zero flag, stack register, and carry flag. If any of the output is zero, my zero flag will become 1. I will stack register for push and popcorn and for some other instruction. My stack register works in last in first out manner. And I have used carry flag for addition and subtraction operation. If there are any bit overflow, my carry flag will show the value 1. These are all the instruction according to my ID that I was given, and I have performed this operation. Now, if I go to the code, I can explain it to you. Here is my code. You can see that I have used 4-bit input, 4-bit output, and 4-bit instructions. I have used the data memory register and stack memory register. And if you go to the RAM section, the lower part of my RAM section contains the instruction, and the upper part of the RAM section contains the memory address register. And these are the operations. If we go to the code, we can see that the first task I have to perform was addition. So I have used carry flag for this operation because of if there is any overflow, the carry flag will become 1. And I have added the inputs A and B. Here I have subtracted the value of input A and B. Here the exchange operation, the A and B will exchange their value. Here move B address is just like the output value of B will get the data memory address. Now here is the output value B will become equals to the input value of B. Here jump not equals to 0 address, so it will if the 0 flag is not equals to 0, then my address pointer will go to the address value. Here the right carry rotate, so the value of A will shift 1 bit, will rotate 1 bit right. Here the move B byte address, move B byte instruction, so the output B will become have the value of the address. Here the jump, so it's an unconditional jump, so my address pointer must go to the address value. Here the pushes, so I have pushed the value of A to the stack memory. And when I have to perform the pop command, my stack pointer decreases value 1 to go to the previous stack value where I have stored the value of A, and it popped the value. Here is the call address and return. Return is just like the IP will return its previous value from the stack. If we go to the vector waveform file, you can see that my first operation was to add the two values. My input A was 5 and B is 2. So it has added the value and the value becomes 7. The second operation was to subtract the value. So after subtraction, my value becomes the 5 minus 2. So it equals 3. The third operation was to swap, exchange their value. So A will be 2 and B become 5. So they exchange their value. The fourth operation was to move the address. So the value of B has become moved to the address pointer, and the sixth and seventh their jumps not equals 0 and right carry rotate operation. If we go to the some of the push command, here this is the 10th command that the value of A will be pushed to the stack pointer. So the value of A was 5, so the value of 5 was pushed to the stack memory 5. And after that it was the pop command, so the 5 will go, the value of stack 5 will go to the A and the stack will become 0. And if we go to some other operations, the return and call address operation, the return is like IP will retain its previous value from stack. So the IP has gotten its previous value from the stack. And lastly, the halt operation. So I have added all the instruction and the output from in the slide. So thank you all.